My name is Sean Kircher.
My name is Josh Leyland.
Connor Hack.
I'm Anton Similian.
And we're Team Goldfish. So our goal for this project was to create a vehicle with 4 wheels that are free to rotate, filling within a certain dimensional requirements, as close as possible to 50 grams, capable of holding a minimum load of 1,000 grams, and it required a drag sensor hook. And we wanted to fulfill these requirements while minimizing drag as much as possible.
All right, so some bit of our strategy for this project. We tried to we all agreed that a design that was smooth, kind of round and oblong shape would be best to keep that drag coefficient low. And we thought about, maybe sanding something out of wood or something like that. But we eventually settled on, SolidWorks would probably be the best route. And Sean had access to a 3D printer at work, so we wouldn't get tied up in the lab here. So we thought that would be the best route. 3D printing would be easy, fast, and cheap. Could do that access. And we had to make sure during the design process as well that the car would be easily 3D printed and wouldn't come out looking differently than the way we designed it here. And Connor's going to go into a bit of that design steps and processes.
So the lowest drag shape in nature is a teardrop. So we modeled our car after that, utilizing a combac rear end to limit the length of the car while keeping the teardrop shape. One of the challenges we found was adjusting the frontal radius of the car to properly enclose the wheels to reduce the amount of drag and not have a high pressure area caught in the wheel well. That would slow the car down. One of the things we did to improve the design of the car was to lower the frontal area of the car by adjusting the dimensions of it, the width of the car, the height of the car, while keeping a round exterior, but not having it be too large at the same time.
So overall in our project, we learned that sometimes you have to make last-minute adjustments even when you 3D print a car. So we had to reduce the weight of it because it weighed a little bit more than what we thought it did. So we ended up taking it apart and just taking out some of the weight, removing some of the material and putting it back together. So that taught us that we need to always be ready for adjustments in case they're needed. We also learned how to use a model to model something that would be bigger. So we calculated the Reynolds number, and that would give us a dimensionless unit to actually model something bigger with, and we can use that in our futures if we make a model at whatever job we're at. Say it's for a vehicle and we need to test it at a small scale, we can test it on that small scale and make something bigger and better.